Hi friends, this is going to be our new video on normal distribution. So this part 1 video on normal distribution will help you to know about what is meant by the normal distribution, what are its going to be its properties, and how can you put into use with the parameters known, and how can the transformation be aided through a variable called as z. Plus, we will see instead of integration how you can evaluate the normal distribution values using your normal tables. So, let us quickly move on to the video. Next, we have the normal distribution function, which is going to be a theoretical continuous distribution to be defined as f of x is equal to 1 by sigma root 2 pi e power minus half x minus mu by sigma the whole square. The random variable x varies between minus infinity to plus infinity. So the integration is from minus infinity to plus infinity f of x dx. And what is our f of x? 1 by sigma root 2 pi e power minus half x minus mu by sigma the whole square. Now, what are the elements present over here apart from this x? E is the exponential function, pi is going to be the constant, 1 by 2 pi is the constant. So, apart from this x, e, 2 pi, we see two things called as x and mu which is present over here. So, these two quantities x and mu are referred as the parameters of the normal distribution. Now, of the two quantities, mu represents the mean of the data or mean of the normal distribution, and sigma square represents the variance. So, sigma square represents the variance. If sigma square represents the variance, so what will sigma represent? Sigma will represent the standard deviation of the normal distribution. So, you normally say that x follows normal distribution with parameters mu and sigma. Mu for mean, sigma for the standard deviation. Some authors also use the notation of like x follows normal distribution with mu comma sigma square. So we need to be very careful whether they have given us the variance of the data or have they given us the standard deviation of the data before moving on to the problem and then fixing it. So this is all about normal distribution. As such, if you are going to see, I need to integrate this function from minus infinity to infinity. 1 by sigma root 2 pi means it seems like a jargon for me, right? So we need not have to bother about integrating such a complicated term. So to aid this, what happened? An alternative was available, which is called as standard normal distribution. What happens over here in the standard normal distribution is the function which we had as f of x has now turned out into a function of z. So how is this transformation aided? Transformation means change of one format to another format. So from the x format, I have transformed it into z format. So how is this transformation given by? Z is equal to x minus mu divided by sigma. So the transformation from x to z is aided by z is equal to x minus mu by sigma. So now we can see that wherever we had sigma, that has been replaced, and what you had over here in the numerator we had x minus mu by sigma. And what do you know about this x minus mu by sigma now? It is going to be z. So it becomes minus half into z square, 1 by root 2 pi. So z also varies between minus infinity to infinity. Rather than the integration which seemed over here, which is going to be a very big expression, now this has become a little smaller one for us. So it has become e power minus z square by 2. So this distribution, which is going to be a normal distribution with n of 0, 1. What do we mean by n of 0, 1? Normally we say that x follows normal distribution with mu, sigma. So now I say x follows normal distribution with 0, 1. So what happens in this case? X is replaced as 0 and sigma is replaced as 1. In which case the function which was 1 by sigma square root of 2 pi e power minus half into x minus mu by sigma the whole square is now converted as, what is the value we are giving for sigma? Sigma is taking the value 1. So it becomes 1 divided by square root of 2 pi e power minus half into, how we are replacing this with, this is replaced as z. So this becomes z square. So now this quantity which is in x has now turned out a quantity in z. So you name it as phi of z. So when we replace mu1 sigma with 0 and 1, the normal distribution is referred by the name standard normal distribution or standardized distribution. So this now turns out the first format into a little easy format. Now even this seemed to be a tough part to handle, and hence what has happened, God formed a table format for us which he gave, so that instead of integration we can just look into the table and then get our answers. So merely substitution of the answers by taking the required area will give us the required probability. So we will analyze the reading of table or how to compute the values from the table in the next video in a detailed way. Now we have converted the variable x to z. Now we will have to see by what ways the properties of the normal distribution curve is going to be helping us to know more about the details of it. So in the next part we see now what are going to be the properties of normal distribution curve. So the first property says that normal distribution curve is a bell-shaped curve. So what is going to be the shape of the curve? The shape of the curve is bell-shaped. I hope you would have seen bell in temple or in church and so on. So how will it look like? It will look like just a flow curve. Go top over here and then it comes here and gradually decreases. So this is something like this, a bell shaped. So this represents a bell. So what is going to be the shape of the curve? It is a bell shaped curve. So the normal distribution curve is a bell shaped curve. It is symmetric about the ordinate at x equal to mu. Symmetric. What do you mean by symmetric? It is equal to both sides. So you say that it is going to be something like a mirror image. And where is the mirror image form? About the ordinate. Ordinate means y-axis. And which line of your y-axis? This is going to be the line. Say we are going to have it as, so let us make it into the center. So this is going to be the line. So what is the name of the line? X equal to mu. So keeping this line as a center, what happens to the left and to the right? The images are mirror images of each other. That's what you name as symmetric. So symmetric means how much of a portion is available in the left, same portion is available in the right. Okay, so it is symmetric about the ordinate x equal to mu. The third point is that the curve is unimodal. Uni meaning one and modal meaning peak. So it is going to be one peaked curve. So how many peaks we have? We have just one peak. In one peak, the value is going to attain the maximum value over here at the point x equal to mu. So when x becomes equal to mu, what will happen over here? When x is becoming equal to mu, this part will now vanish and e power you will have it as 0. What do you know about e power 0? E power 0 is 1. So what will be the maximum value attained by the function? It will be 1 by sigma into square root of 2 pi. This will be the maximum value attained by the function. And at which point does it attain? It is attained at the point x equal to mu. Next property is that the total area under the curve is 1. Why is it total area is under the curve is 1? We know that integral from minus infinity to infinity f of x dx is equal to 1. We know this as property from our random variables. So what happens over here when this x varies between minus infinity to plus infinity, and I am going to start evaluating the area over here, the here and so on. If I move on estimating the area till plus infinity, how much is the total area covered? The total area covered is 1. That's what we say over here. The total area under the curve is equal to 1. What is the next property? The next property says that mean, median and mode coincide and lie at the center of the normal curve. We already know that the center of the normal curve is x equal to mu. What does mu represent? Mean. So x equal to mean equal to mu. Median is also equal to mu, and mode is also equal to mu. This mean, median, mode and all are your statistical averages which will help you to determine the nature of your data. So when mean, median, mode, what happens? All of them lie in the same point. Say they coincide and they lie in the center of the curve. Next comes the point that the x-axis is an asymptote to the curve. I don't know whether we have come across the word asymptote in your lower grades. A curve that meets the other curve at infinity is called as asymptote. Okay, so what happens over here? It is x-axis is going to be asymptote. So which is our x-axis? This is going to be our x-axis. So this is going to be our x-axis. So what they say is this curve is going to go on and on and on, and where does it meet? It meets the curve at infinity. So in the same way this point also goes extending and it meets the curve at infinity. So a curve that meets it at infinity, so it is very closer, but it is not actually touching it over here. So it moves very close to each other, then you call it as asymptote. So this line which is over here, which moves very closer to the curve and touches it infinity, is called as asymptote. So which acts as an asymptote? The x-axis is going to act as an asymptote to our bell-shaped curve. So these properties will help us to determine the probability in a better way. Now the important point to be noted, one more time we will recollect, it is a bell-shaped curve. So it is going to be symmetric. Symmetric meaning this half is going to be the same as this half. So what is going to be the total area? Total area is 1. So this portion of it, which is going to be half the area, which is half the area, this is half the area. This half the area is going to be of value 0.5 for me, and this half of the area is going to be 0.5 for me, because it is mirror image of each other. The curve is unimodal. It reaches the highest value, the maximum value at this point called as the peak, and the curve meets the x-axis at infinity. So it is going to be moving closer and closer from here to here. Then the area becomes very small and it meets at infinity. The mean, median, mode, all of them lie at the center, and this point is given as x equal to mu. When I am going to transform this curve from x variable to z variable, then what will happen? I know z is equal to x minus mu divided by sigma. So when this x is equal to mu. So when I put this x as mu, so I have mu minus mu divided by sigma. So what will happen to my z? This point will become z equal to 0. So the curve will now become symmetric to the line z equal to 0, and hence the problem will be solved for this.